Hello everyone, my name is Marek Pikuła. I'm from Samsung R&D Institute Poland, and today I'm going to present a project I've been working on throughout the last year, which is CI multi-platform. So first a few words about myself. I have background in FPGA engineering, and at Samsung I'm working mostly on platform software. The main goal for me was recently porting Tizen OS to RISC-V and then supporting some system libraries and porting them to RISC-V. And because of that I also got involved with CI and enablement of CI for RISC-V. So jumping straight into the problem I'm trying to solve with CI multi-platform. So if you have a library or an application that has some platform-specific code, be it some specific SIMD optimizations or some specific behavior which is very much platform-oriented or architecture-oriented, then you need to either cross-compile it or try to do some weird stuff, and you quickly run into an issue that if you have some dependencies, you need to somehow include them in the build, then you need to somehow run the test, and it can get really tricky really fast. And second point is that when you're trying to push your code upstream, maintainers need confidence in your code. So in our case, we were trying to upstream our RISC-V vector extension support for Pixman library, and well, there was no support for RISC-V in CI pipeline at freedesktop.org at this time, and the maintainers simply didn't know the specifics of RISC-V vector, so we couldn't really prove that we are able to do the stuff that the library needs. And third point is hardware scarcity. So in case of RISC-V, there are no RISC-V CI runners available pretty much, and also the boards that supported RISC-V vectors at the time were pretty scarce, so the maintainers couldn't really just go buy a board and test our patches. So let's try to make a multi-architecture CI as boring as possible. We want to base it on reusable GitLab CI templates. It's GitLab because we targeted freedesktop.org at first. We want to use layered OCI or Docker images to have flexibility for the projects. We want to use QEMU user mode emulation because we don't have hardware support for everything. And we will also want to include coverage and coverage summary across all the targets that we have. So what are the building blocks? First we have the OCI images, which are layered, so you can have, depending on your project, you could have a base GNU layer, then add LLVM as well if you want to test for both compilers. Then you can add your build tool. In our case we support for now only Mezen, but we have plans to extend it to CMake and AutoTools. And then you can add another layer with your project dependencies. Then we have reusable templates. In our case, as I said, it's only for Mezen, but if you have your own scripts that you want to run on those different targets, you can use it. And we extensively use QEMU user mode, which pretty seamlessly integrates with the OCI images. A few words about target naming. So we have currently Linux native targets and Windows cross-compilation targets using Wine. Then we have native and cross targets, because for some targets, for example 32-bit big endian MIPS, there is no Debian image, so unfortunately we need to cross-compile for those targets. And then the final part is the architecture. So how to use the project? Here's a little bit kind of call for action. If you have some platform-specific code in your project and you use GitLab CI, then you can try to use this. So first you need to check which targets have native runners on your GitLab instance. Currently we support natively gitlab.com and freedesktop.org runners, which is x86 and ARM. Second, do I need custom dependencies or build system? If yes, then you need to define those layers by yourself. If not, then you can straight up use the pre-built images. And then either if you use Mezen, then it's great because you can use the templates which we provide, or if not, you can just run your specific build and test by yourself. On the left, you can see basic example using parallel matrix for 3 different architectures, running some basic script. So a few hot takes. That's what we came here for. So how to make it all possible? We have Debian base images. We chose Debian because it has the widest support for different architectures. First, there are multiple natively supported, so official architectures, and also there is extensive library of ports for Debian. So for the upstream pre-built images, we can just pull them from upstream and use them. But for the ports, we need kind of elaborate setup. In this case, I tried to do this on like as little privileged as possible runners. So first we have build a main builder image. This is our first layer of abstraction. Then we have the Bootstrap builder base image. It's a standard Debian tool for building base images. And then we have the Debian base image builder layer, which internally uses Prut, which adds another layer of abstraction. And yeah, it was pretty fun debugging it all in CI, and yeah, I was really skeptical at first if it will work, but magically it works in one very specific version of Fedora base image, but it works. And that allows us to utilize OCI caching, so that we don't need to rebuild the Debian images every time we run the CI. And that allows us to have the very similar baseline, because the Burrow type and the Bootstrap are the tools that are used for the official upstream images. So we have very similar base images for all the architectures that we support. And then on top of that, as I said, we built additional layers, so GNU toolchain, LLVM, Maven, and whatever you have in your project. Second nice thing about utilizing QEMU for running the tests is, well, first you can of course have your native runners. If you have RISC-V boards and you can add them to your CI, then that's great. But on the other hand, utilizing QEMU allows you to have some very specific virtual target configuration. So in case of RISC-V vectors, you could configure the vector length, vector register length in QEMU, which allows you to easily change the virtual hardware configuration, and that's actually allowed us to catch some early bugs in our RVV implementation. It extends platform coverage beyond what is already available. So at this time that we were developing the patches, we had only board with VLAN of 256. But in future there will be boards with bigger VLANs, and right now we can test those scenarios and be ready for future hardware. So what's next for the project? First, it's a call for action to all of you. If you have a project that has some platform-specific code, then I would be really happy if, and it runs on GitLab, I would be really happy if you came and tested it. I would really appreciate any kind of feedback and bug reports. You could push them to the official GitLab repo, and if you have any suggestions what could be done to improve this, of course, besides adding more features, but what are the specific scenarios that you would see useful for you. There is also this nice badge that you can stamp on your project if you're using CI multi-platform. Yeah, and in the pipeline there are more build tools, so we plan to support also CMake and Auto tools with extensive templates and coverage summarization. I think it's really nice to have this aggregate coverage summary, because if you have multiple targets, then, well, you have multiple summary reports for different targets, but then we are able to compress all this into one single result and present it nicely in GitLab, for example, for pull request. So that's about it. Here's the QR code for the project. Please contact me, please use the project, and I would very much appreciate the feedback. And if you have any questions, I'll be there around, or I'll answer questions online.
You have 5 minutes that you can take questions.
Yeah, that would be great, actually.
So do we have questions for Mark? One question,
Yep.
yes, go ahead.
Can you say something about performance penalty when running typical build scenario like QEMU?
Yeah. So the question is about performance penalty when you're running QEMU. So, well, first of all, sometimes running in QEMU is the only way because you don't have the native runners. And in case of RISC-V, actually, because there are starting to appear some options to include native runners for RISC-V, and we tested them with the Cloud-V, Cloud-5 runners. And curiously, the current hardware is slower than QEMU running on big runners available at freedesktop.org. So that's interesting thing. On the other hand, when you have some SIMD extensions, in case of RISC-V, it runs much slower than on real hardware, so it's a kind of trade-off. So for building images, I would say running it with QEMU is the fastest. If you have some very specific performance-oriented code, then using the native runners is always the best idea. And this project also allows you to interchange those. So you could build your images on the native runner and then use the QEMU runner and then use the native runner to run your actual tests. So, any more questions?
So if you are on GitLab, would you suggest, for example, when you start with Gutenberg, just a server connection to another GitLab instance that is a mirror, just do this, or how would you do it if you are not on GitLab?
Yeah, so the question is about integration with Codeberg, basically, right? So honestly, I'm not really familiar with how Codeberg does CI, so I'm not sure. But what you could do for sure is to just mirror your repo on some GitLab instance, be it the official gitlab.com or freedesktop.org or wherever, and you could just grab those templates. But yeah, I'm not 100% certain how it works on Codeberg. Yeah. So any other questions?
Okay, I think one more question maybe. We have 3 minutes.
Yeah.
I missed a few minutes of the talk, so apologies, but why not cross-compile to RISC-V?
Yeah, so the question is about why not cross-compiling. It's an option for sure for some projects, but once you get to more and more complex projects, which like multiple dependencies and maybe some target specific dependencies, then you quickly run into a lot of maintenance overheads when trying to do it properly. It's in case of CI multi-platform, it's much easier because you have basically native Debian images. So in your dependency layer, you could just apt-get whatever dependency you need, and you don't need to worry about cross-compiling those dependencies and so on. So, and it's because we use the OCI like multiple targets for the OCI images. You could have very specific dependencies for each platform that you support. So you don't need to have like one set of dependencies. You could have multiple variants of dependencies based on the platform. Yeah. Yeah. All right.
1 minute.
Yeah. So.
Any other questions? Quickly. Last question. No? Okay. Thank you.
Right. Thank you very much.